Okay, at the end of the last video, I asked you to write down the 6 derivative formulas that we have for the hyperbolic trig functions, and then translate them to the corresponding integral formulas. So, I know that the derivative of sinh is cosh, which means the general antiderivative of cosh is sinh x plus c. Similarly, the derivative of cosh is sinh, so if I integrate sinh with respect to x, I get cosh x plus c. Derivative of tanh is sech squared, so I can integrate sech squared x dx, and I will get tanh x plus c. Now, with hyperbolic trig, the 3 that are defined in terms of the reciprocals, sech, cosech, and cotanh, those are the 3 that have a negative sign in the derivatives. And certainly I could have written here that if I wanted to take an antiderivative of negative sech x tanh x with respect to x, I would just get sech x plus c. Usually the way the integration formula is written is you're given the opposite of this derivative. If there was a negative sign, you're usually given it without the negative sign, and you just recognize that's the opposite of the derivative of sech, so an antiderivative is negative sech plus c. Same thing with cosech and same thing with cotanh. These are the versions of the formulas that you'll see in your textbook and that you'll find in most standard textbooks. Okay. So, super important that we know these derivative formulas so that we can recognize when we have a derivative or we have the opposite of a derivative so that we can take our antiderivative. Okay. Now, I also want to take a look at the inverse trig functions, because those are going to be integrals that it would be really difficult to do unless we happen to recognize that we have the derivatives. Now, with the inverse hyperbolic trig, I do not want you to waste your time memorizing the derivative formulas for the inverse hyperbolic trig functions. In 3B, you learn another technique so that you never need to have those memorized. And if you take 3B with me, I will never ever give you credit for having memorized the derivatives of the inverse hyperbolic trig functions. They're just, it's not that useful information to have unless you're really working with that sort of problem all the time. Okay. But the regular inverse trig you should know. So let's remember the derivative of arc sine of x was 1 over root 1 minus x squared. Now what that means is if I wanted to integrate 1 over root 1 minus x squared dx, that looks like a hard problem unless I say, oh look, that's the derivative of arc sine. This is arc sine of x plus c. So I really do need to be familiar with that formula. Now, I know that the derivative of arc cosine of x is very similar. It's just the opposite of that. And usually when we're writing our integration formulas, we don't write the negative sign, we just get the opposite function. So I could write integral of 1 over root 1 minus x squared dx is negative arc cosine of x plus c. That's also true. They are both true. Now, that does not mean that arc sine of x is the same as the opposite of arc cosine of x. They're not equal. Remember, the c is an arbitrary constant, so this c is not necessarily the same as this c. But what we can see is that arc sine and negative arc cosine actually have the same derivative, 1 over root 1 minus x squared. What that means is that the difference between them, so arc sine of x minus negative arc cosine of x, must be some constant. And here, this isn't an arbitrary constant. There's a specific constant that actually works. But because these two functions have the same derivative, arc sine plus arc cosine of x is constant. And to see what that constant is, I can actually just pick an easy number to plug in. If I were to plug in 0, arc sine of 0 plus arc cosine of 0, well, arc sine of 0 would be the angle between negative pi over 2 and pi over 2, whose sine is 0, that's 0. Arc cosine of 0, that's the angle between 0 and pi, whose cosine is 0, and that's pi over 2. It's pi over 2. Turns out arc sine plus arc cosine is always pi over 2. Okay. That's not a fact that you need to have memorized, but it is a fact that falls out from the fact that I could integrate this either of these two ways. This is more commonly what we'll see, but either option is correct. Okay. Now, I know the derivative of arc tan of x is 1 over 1 plus x squared. So that means I know that an antiderivative of 1 over 1 plus x squared is going to be arc tan of x plus c. You'll notice I'm kind of in the habit of writing my c's as lowercase c's, and the book writes them as capital C's. I mentioned it does not matter. It does not matter. Okay. All right. And then I should also know that the derivative of arc secant of x, that was 1 over x times the square root of x squared minus 1, which means if I wanted to take the general antiderivative of 1 over x times the square root of x squared minus 1 with respect to x, I would get arc secant of x plus c. Now, these are the only 4 derivatives of inverse trig functions that I expect you to have memorized. I do expect that you could derive the formulas for any of the 6 inverse trig functions. Turns out the derivative for arc cotangent is just the opposite of this, and the derivative for arc cosecant is just the opposite of this. So they don't actually give me any new formulas when it comes to integration. They just give me other options for these integrals. So you're fine if you're familiar with these 4 derivative formulas, and really just either of these and these 2 for the integration formulas. But you do want to be able to recognize those, because otherwise it's going to be a pretty tricky integral, because there's really no way to write any of these functions as combinations that we're connecting by just addition, subtraction, and scalar multiplication, which are the only things we have rules for at this point, of just powers and, well, basically powers is all we have here. But, trig functions and exponentials and the ones that we know the rules for. Okay?